So let's talk about how to change variables or use substitution if you have definite integrals, because this can be kind of tricky. Keep in mind that these bounds a and b are bounds on the variable x. So whenever you evaluate a definite integral using change of variables, you basically have two choices. Number one, after evaluating the integral in terms of u, you can convert everything back to x and then use the fundamental theorem of calculus as normal. Or number two, you could convert your upper and lower limits of integration to u values and use the fundamental theorem of calculus without ever having to convert back to x. So it doesn't matter, you're going to end up with a number either way. So I'm going to show you the same problem using both methods. So if I'm just looking at the integral from 0 to 2 of x times x squared plus 1 cubed dx, I would let my u here be equal to x squared plus 1, which means du is going to be 2x dx. Okay, so if I'm going to integrate this, I'm going to multiply by 2 over 2, and I'm going to bring one of my 2's in. So I'll have 1/2 times the integral from 0 to 2 of 2x times x squared plus 1 cubed dx. And notice the 2x and the dx makes my du, so this is 1/2 times the integral of u cubed du, and this is from x equals 0 to x equals 2. Now at this point, everything's basically the same, okay? But I have two options. So I could go from here to option 1, which says we integrate and then we convert everything back. So that's going to give me 1/2 u to the 4th over 4 from x equals 0 to x equals 2. The only reason I'm writing x equals is just to remind myself that that's what that variable, what those those numbers get plugged into. So this will be 1/8 times x squared plus 1 to the 4th from 0 to 2, which will be 1/8 times, we'll have 2 squared plus 1 to the 4th minus 0 squared plus 1 to the 4th, now that everything's back in terms of x, which will be 1/8 times 5 to the 4th minus 1 to the 4th, or 1/8 times 624, which is equal to 78. So that's one option. Option 2, from here, we can observe that we're going to have that same integral. That's going to be 1/2 u to the 4th over 4. And instead of just plugging in our bounds as in terms of x, we know that when x equals 0, that gives me u equals 0 squared plus 1, because that's our u, which is 1. So this bound is now going to be in terms of u. And when x equals 2, u is going to be 2 squared plus 1, or 5. So this is going to be u equals 5. So when I integrate this, I'm just going to have 1/8, and that'll be u to the 5th. I'm sorry, we've already done this. 1/8 u to the 4th from 1 to 5. So that'll be 1/8 times 5 to the 4th minus 1 to the 4th, which is 1/8 times 624, or 78. So either way you want to do it is fine. Here you just have to keep track of the fact that you only want to plug into x. Here you have to actually convert your bounds up front, but then you never have to think about x again. I'm never going to tell you you have to do this one way or the other. It's completely up to you. Either way works just as well. It just kind of depends on what your preference is. The only thing you don't want to do is plug a 2 straight into a u. As long as u's get plugged into u and x's get plugged into x's, then that's all that matters. I tend to prefer option 1, so that's what I'm going to go with. So I've got the integral of 1 from 0 to 4 of 1 over the square root of 2x plus 1. So I'd let u equal 2x plus 1, which means du is going to be 2 dx. So I need the 2 over 2 here, and I'm going to bring that in. So this will be 1/2 times the integral from 0 to 4 of, let's see, we'll have 2x plus 1 to the negative 1/2 times 2 dx, or 1/2 times the integral from x equals 0 to x equals 4 of u to the negative 1/2 du. So this is going to be 1/2 times u to the 1/2 over 1/2 from x equals 0 to x equals 4. So these 1/2s actually cancel. And I just have the square root of u from x equals 0 to x equals 4. And that's the square root of 2x plus 1. Now we're just in x, so it doesn't matter. And this would be the square root of 2 times 4 plus 1 minus the square root of 2 times 0 plus 1, which is the square root of 9 minus the square root of 1, which is 3 minus 1, which is 2. And if you work this out by the other method, you'd get the same exact answer. It won't change the answer at all. Another neat trick involves even and odd functions. Remember, even functions are those where f of negative x equals f of x, and odd functions are those where f of negative x equals negative f of x. And if f happens to be an even function, then the integral from negative a to a, now that's very important, it's negative a to a, of f of x dx is equal to 2 times the integral from 0 to a of f of x dx. And if f happens to be an odd function, then the integral from negative a to a of f of x with respect to x is actually equal to 0. So if I'm looking at this one right here, I've got x squared times x squared plus 1. If I were to find f of negative x, this would be negative x squared times negative x squared plus 1. And you can see that this would be x squared times x squared plus 1, or f of x. So this is an even function. So if I wanted to, I could make this 2 times the integral from 0 to 2 of x squared times x squared plus 1. Now this one doesn't actually have a chain rule capability. You may look at it and think that, but if you were to let u be x squared plus 1, you would only need 2x on the front, and we actually have x squared, so we have an extra x here. So the best way to go about this is actually just to distribute this out. So this will be x to the 4th plus x squared. So I'll have 2 times x to the 5th over 5 plus x cubed over 3, and that's going to go from 0 to 2. And this will be 2 to the 5th over 5 plus 2 cubed over 3 minus 0 to the 5th over 5 over 0 cubed over 3, or plus 0 cubed over 3, which is 2 times 32 over 5 plus 8 over 3 minus a 0, or 272 over 15 if you take care of that arithmetic. And when you look at this one, we've got the integral from negative pi over 2 to pi over 2 of sine of x cosine of x with respect to x. F of x here is sine of x cosine of x. So f of negative x would be sine of negative x cosine of negative x. And sine is odd and cosine is even. So that means this is negative sine of x times cosine of x, or negative f of x. So the whole function is odd, and since we have negative a to a, this is just 0. Now, if you happen to miss this one, you could let u be a sine of x, so du would be cosine of x dx. So it would be the integral from negative pi over 2 to pi over 2 of u du, which would be equal to u squared over 2, and that's from x equals negative pi over 2 to x equals pi over 2. So this would be sine squared of x over 2 from negative pi over 2 to pi over 2, which would be sine squared of pi over 2 divided by 2 minus sine squared of negative pi over 2 divided by 2, which ends up giving me 1 squared over 2 minus negative 1 squared over 2, which is 0. So even if you miss the shortcut, you would still get the answer as 0 eventually. It just might take you some more steps.